A compound surd is an expression containing two terms, at least one of which contains a square root, which cannot be removed. So for example, 3 plus 2 root 5 and 2 root 3 minus root 2, they're both compound surds. So containing two terms. The surd conjugate, or just known as the conjugate, of a compound surd is found by changing the sign between the two parts. So for example, if you start off with 2 minus 3 root 5, you change the minus to a plus, and this is the surd conjugate. If we have 5 root 2 minus 2 root 3, we change the minus to a plus, and again this is the surd conjugate. And if we have 2 root x plus 1 minus root x, we change that minus to a plus. And it works the same if you're changing a plus to a minus. If a compound surd is a plus b, then the conjugate is going to be a minus b. When these are multiplied, we get a plus b times a minus b, which gives us a squared minus b squared. Because of this, whenever a compound surd is multiplied by its conjugate, the result is always a rational number, which means that there's no square roots. So, for example, if we have root x plus 2 minus root x plus 1, the conjugate of that is going to be just change this minus to a plus. If we're to multiply both of those together, so if I stick brackets around this, and I stick brackets around this, and I multiply them together, I'm going to end up with a squared minus b squared in that format, which is basically the first term squared. So the first term in this case is root x plus 2, so it's going to be root x plus 2 squared. And then I'm going to have a minus, so I'll have a minus. And then the second term, which in this case was a b, will be squared, but in our example is root x plus 1, so it's going to be root x plus 1 squared. So the first term squared minus the second term squared. Now, if we want to square the square root of x plus 2, well, the square root and the squared part will just cancel each other out, leaving us with x plus 2. And if we want to square the square root of x plus 1, again, they will cancel each other out, the square root and the squared, leaving us with x plus 1. And x minus x just cancels, and 2 minus 1 leaves us with 1. So a fraction that contains a compound surd on the bottom line can be written with a rational denominator by multiplying above and below by the conjugate of the bottom line. And this is called rationalising the denominator. So let's have a look at a couple of examples. Rationalise the denominator of 1 over 4 root 8. Give your answer in the form of root 2 over p, where p is a positive integer, so a positive whole number. Now in this example, our surd on our denominator is not actually a compound surd. So it's just a surd on its own. So all we actually have to do in this example is multiply top and the bottom by the actual surd itself, which in this case is root 8. So I'm going to multiply top and bottom by root 8, because what I do to the top, I do to the bottom, what I do to the bottom, I do to the top, because by multiplying by root 8 over root 8, you're really just multiplying by 1, so you're not actually changing the value of it. So 1 multiplied by root 8, top by top, is going to be root 8. And 4 root 8 multiplied by root 8 is going to be 4 root 8 root 8. Root 8 gives us 8. And 4 by 8 is 32, and we just bring over the root 8 as our numerator. Now, at this point, we have actually rationalised the denominator. The denominator doesn't contain a square root anymore. But our question specifically asks it for the form root 2 over p, and p has to be a positive integer. So we've got root 8 as our numerator, and we want root 2 as our numerator. So we're going to factorise root 8 to give us root 4 root 2. And the square root of 4 is going to be 2. So we've got 2 root 2 over 32. And if we divide by 2 on the top and the bottom, 2 divided by 2 goes once. And 32 divided by 2 goes 16 times. So we get root 2 over 16. And that's what we wanted. Root 2 over p, root 2 over 16. And 16 is indeed a positive integer. Okay, in this example, we want to write root 18 plus 8 over root 2 in the form of a plus b root 2, where a and b are integers. So integers are positive or negative whole numbers. So again, in this example, we do not have a compound surd as our denominator, we just have a surd. So all we have to do is multiply the top and the bottom by that surd. So we're going to multiply top and bottom by root 2. So 18 by root 2 is going to be root 2 root 18. And 8 by root 2 is going to be 8 root 2. And root 2 by root 2 is going to be 2. Now root 2 root 18 is going to be root 36 because 2 by 18 is 36. And 8 root 2 can stay as it is for the moment. The square root of 36 is going to be 6. Bring down the 8 root 2 and the 2. And we notice that we have 6, 8 and 2. And all of those can be divided by 2. 6 divided by 2 is 3, so we just bring down a 3. 8 divided by 2 is 4, so we bring down the 4, stick on the root 2. 2 divided by 2 is 1, so we don't need to write the 1 in anymore. So our answer is 3 plus 4 root 2. Which is indeed in the form of a plus b root 2, where a and b are integers. So 3 and 4 are both integers. They are positive whole numbers. They could have been negative whole numbers if we wanted, because an integer is a positive or a negative whole number. Okay, so now we're going to have a look at an example where we want to rationalize the denominator, and the denominator is a compound surd, so containing two terms. So without using a calculator, express 1 plus root 3 divided by 2 minus root 3 in the form of k plus m root 3, where k and m are elements of the natural number set. So k and m must be positive whole numbers. Now, very important to note that root a times root a will always give us a. So the conjugate of the bottom of the line is going to be 2 plus root 3. So our denominator was 2 minus root 3. So our conjugate is going to be 2 plus root 3. So that minus became a plus. And this is what we multiply above and below by. So this is what we multiply the numerator and the denominator by. So we have 1 plus root 3 over 2 minus root 3. And we multiply top and bottom by 2 plus root 3. So technically you're multiplying it by 1 because 2 plus root 3 over 2 plus root 3 will give us 1. So you're not actually changing the value of our original fraction. So what I'm going to do is just stick brackets around each of our compound surds. So 1 plus root 3 just gets brackets put around it. 2 plus root 3 gets brackets put around it, and they're stuck together. And then I do the same with the denominators. Stick them together with brackets around it. So I'm going to multiply my numerator over here. So I'm going to crack open my first egg. I notice that I've got 2 eggs, so when I want to do binomial expansion, I'm going to crack open the first egg and bring the first term over here and stick on the second egg, which I did not crack open, and then bring over the second term plus root 3 and stick on the second egg again, which I did not crack open. Then I just multiply out. 1 by 2 is 2, 1 by root 3 is root 3, root 3 by 2 is 2 root 3, root 3 by root 3 is 3, because root a by root a is a. So now I'm going to multiply out my denominator. So again, I'm going to crack open the first egg and bring over the first term, which is a 2. Stick on the second egg, which I did not crack open. Bring over the minus root 3. And again, stick on the second egg, which I did not crack open. So whenever I'm doing binomial expansion, I notice I have 2 eggs. I'm going to crack open the first egg and stick on the second egg to each of the terms in my first egg. So 2 by 2 is 4. 2 by root 3 is 2 root 3, minus root 3 by 2 is minus 2 root 3, and minus root 3 by root 3 is minus 3. So I'm going to bring over my 4 terms into my numerator, and what they've actually done in this example is instead of multiplying it out the long way, which is what I like to do, just so I don't make any mistakes, they've squared the first terms, the first term being 2, they've squared it. They then put in a minus, and then they've squared the second term, so root 3 squared. So this is basically the opposite of the difference of factorising by the difference of 2 squares. But it doesn't matter which way you do it. Either way, our numerator is going to be 2 plus 3, which is 5, and 1 root 3 plus 2 root 3 is 3 root 3. Then 2 squared is 4, and root 3 squared. The root and the squared would cancel each other out, leaving us with 3. So it would be minus 3. So it would be 4 minus 3. Or else you could just bring over the 4 and the minus 3 from here and cancel out the 2 root 3 and the minus 2 root 3. So then we have 4 take away 3, which is 1. So we've got 5 plus 3 root 3 over 1, which is going to be 5 plus 3 root 3. And we want to check, do we have our answer in the format that we were asked for? We want it in the form of k plus m root 3, where k and m are natural numbers, and yes, we do have it in that form.